Okay, so today we are solving exponential equations. Number 2. This is page 121 in your book if you have a book. If you don't, then you can print off the PDF. We're going to do some examples together, and then you're going to have time to work on your quiz. So the problems that I pick are very similar to your quiz. So if you're struggling, please make sure and watch this video. It's lovely. Okay, so here we go. Number 1. When you're solving these equations, you want the bases to match. So my bases do match. I have a 3 on the left and I have a 3 on the right. Then you're going to look at the exponents when the bases are 100% the same, so they have the same number and the same sign, which mine do. Then I look at my exponents. Remember, if you don't have anything there, it's a 1 and not a 0. Okay, because I have 1, 3 there, so that's what this 1 is. We don't usually write it, it's invisible, but it's still there. So, when the bases are the same, you ignore the bases and you look at our exponents. See how that equal sign is in between right there? You're going to keep that equal sign there. Okay? So we're going to rewrite just our exponents. So we have 2x minus 11 equals 1. And then we're going to solve this equation for our x value. So we need to get the x by itself. We're going to do the opposite of minus 11. So we're going to add 11 to each side to get that x isolated. And then we're going to divide each side by the number in front of my variable, which is 2. So x is 6. Okay, so what that really means is if I put a 6 right here in this x, then I should get an exponent of 1. So let's just try. Okay, we're going to just plug it into my calculator, make it do all the work for me. So we have 2 times, that's what it means when the variable and the number sit next to each other. My value of x, we got 6, so we should plug a 6 in. Then parentheses, and then minus 11, and that gave us 1. So this, when you put a 6 in where this x is, it actually equals 1, so the left side equals the right side. So think about it like if I had, a $5 bill, that's the same thing as 1, 2, 3, 4, 5. Like these value for the money are equivalent. They're the same, but they look very different. 5 ones and a 5 look very, very different. So that's what's happening here. 2x minus 11 and 1 look very different. Okay, let's try another one. Let's look at number, I don't love these. We're going to come back. Number 28. There we go. Okay, so on this one, again, I want the same exact number for my bases. When my numbers are exactly the same sign and everything, then I'm going to just focus on my exponents. Notice that my equal sign is here. Okay, so I'm going to ignore my bases and look at my exponents and rewrite the problem. So we have x minus 10 equals 2x plus 5, and we're going to solve for x. Remember, when you have variables on both sides of the equation, you want a variable on one side and a number on the other side. So we're going to pick any of the 4 to move. I'm going to get rid of this negative 10 by adding 10, which gets my 10 away from my variable. Since I added 10 over here, I also have to add 10 on this side. Bring down my 2x, nothing happened to that. 5 and 10 is 15. I want my numbers on one side and my letters on the other side. I already have one letter over here, so it makes the most sense to combine my like terms together across my equal sign. I do that by doing the opposite, so I'm going to take away 2x from this side, leaving just my 15. Sorry, I migrated down a little. And then I also have to take 2x away over here. Well, if I have 1x and I take 2 away, then I'm left with negative x. But I can't have a negative in front of my variable when I'm solving, so we're going to divide each side by negative 1, or flip the signs of everything. But I only have one other number. When I divide my 15 by negative 1, I get negative 15, and that's my answer. So if I plug in negative 15 for this x and negative 15 for this x, the left side and the right side will be completely equal. Okay, now let's talk about more of a complicated problem. So let's go back to the other side. We're going to flip number 6. Okay, on this problem, we almost have the same bases, but this 9 is not above my fraction, it's below my fraction. And this 9 is above my fraction in the numerator. So we have a numerator 9 and a denominator 9, and they need to be in the same. I know that I can move this guy upstairs, so currently he has an exponent of 1. If I move my 9 to the opposite position, I'm going to have the opposite sign. So I'm going to keep my 9 3x, and 5. And I'm going to move this 9 upstairs so he looks exactly the same as this base. When I do that, I'm moving my 9 to an opposite position so my negative is in front of whatever exponent I have, which is 1. Now, since my 9s are both positive 9s upstairs, I'm going to look at my exponents. We're going to rewrite the equation, 3x plus 5, keep your equal sign in the middle, and we're going to solve. I want to get the x by itself, so I want to get rid of the 5. The opposite of positive 5 is negative 5, leaving me 3x. What I do to one side, I must do to the other side. Negative 1 minus 5 is negative 6. Then I need to get the x by itself. We divide each side by 3, and x is equal to negative 2. Yay, that wasn't so bad. Now, what happens if my bases don't match? So let's look at number 29. I know I'm going to have to move this guy upstairs, but this is not 7. And it has to match. It has to be a 7. So I'm going to make a factor tree. And the numbers I'm going to start dividing off. 5, 7, 6, 4, 8, 0, 1 is going to be a 7. We're going to start with a 7. We have to have a 7 because my base over here is a 7. So 7, 7, 7. All right, so 5, 7, 6, 4, 8, 0, 1 divided by 7 is that number. So we're going to write that guy down. 8. Oops, I should go like this since I'm right-handed. Okay, 8, 2, 3, 5, 4, 3. And now we're going to divide this guy by 7. I want to keep going by 7 because that's my base on the other side. And now I get 1, 1, 7, 6, 4, 9. Oops, sorry, I forgot to write my 7. Heavens. Okay, I'm going to divide by 7 again. And I get 1, 6, 8, 0, 7. We're going to keep going by 7. 2, 4, 0, 1. Oh, 7 again. Keep going. 343, we're almost there. 7 is 49. I'm just going to show you. And then 7 and 7. Yay! Love it. Look at that factor tree. Okay, and then we're going to count our leaves. We got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this big number is equivalent to 1 over 7 to the 8th power, which is nicer to write because it's so tiny. And then we still have our 7, 5 minus x on the left-hand side. Remember, I want my bases to match, and when it's in a fraction and the other one is not, my bases don't match. So they either both need to move down or both need to move up. It's easier to move this guy up because he only has one number as opposed to this guy. Because you'd have to distribute a negative, and it's more complicated, but you could. Okay, so there's the left-hand side. We're going to keep that guy the same. We're going to move this guy up to the opposite side of my fraction. When I move him to the opposite side of the fraction, I have the opposite sign on my exponent. Okay, so now, since my bases are 100% the same, I'm going to just look at my exponents. We're going to solve. So I've got 5 minus x equals negative 8. We're trying to get the x by itself, so we want to take away 5, do the opposite of the positive 5 that's already there. Now I have negative x equals negative 13. Okay, then we want to get the x by itself, so we're going to divide each side by negative 1, and x equals 13. Yay! Okay, let's do another example. One more. Okay. Here we are. Wait, hold on. Okay, I'm back. Sorry. Okay, so we're going to do number 3 together. All right, so number 3 is the most different of all of them, but it's actually one of the easiest problems. So my bases don't match. I have a 2 and a 1. That's not even close, okay? So I'm going to keep my 2 because I actually have this cute little exponent on my 2. Now the 1. Here's the problem. I need this right-hand side to match my base over here. And I can't get my 1 on this side because 1 to any power is still 1. So that's not going to work. So I'm going to have a base of 2. So whatever number you have, if you have a number and a 1, you got to pick the number bigger than 1. Okay, now to figure out what exponent goes here, that is the trick. Okay, if I do 2 to the first power, let's just type some stuff in so you can see what's happening. If I do 2 to the first power, I get 2. If I do 2 to the second power, well, I get 4. 2 to the third power. My numbers keep going bigger, but I need to get 1. All right, so let's try a negative. 2 to the negative 1, I get a half, right? Because he went downstairs. So that's only 0.5. That's less than 1. So what number is it? Well, think about it. What number is between negative 1 and 1? 0. So let's try. 2 to the 0 is 1. Well, in fact, anything to the 0 is 1. Like 5 to the 0 is 1. And 1,000, that's more than 1,000. To the 0 is also 1. Any number or any letter to the 0 power is 1. So if you have just a 1, keep the number that you see on the opposite side and put a 0 with your exponent. Now my bases match 100%. I've got a 2 and a 2. So then we look across. We've got negative 4x equals 0. Divide each side by negative 4, and x is 0. Yay! Let's do one more so you can just see how it's done. There's one on this side. Yep, 26. Okay, so I have an 8 and a 1. When you have a 1, just a plain 1, then you want to change your 1 to match this base. So I want this 1 to be an 8 instead. So I have 8x plus 9 on the left and an 8 on the right. Well, the only thing that will make my 8 a 1 is if it has an exponent of 0. Then we look at our exponents because our bases are 100% the same. X plus 9 equals 0. We're trying to get the x by itself, so the opposite of plus 9 is minus 9. X equals negative 9. And we're all done. Hope you had a great time. See you guys later. Bye!